Hello, in this short lecture I will give a proof of the Pythagorean theorem. Pythagorean theorem says that in a right triangle the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So actually we can say that if we look in the right triangle, we can say that the square of the hypotenuse is c squared and is equals to the sum of the squares of the perpendiculars, that is a squared plus b squared. So c squared is equals to a squared plus b squared. So that is what we need to prove. Let's assume that the right-angled triangle ABC is the right side of the drawing. Now a copy of this right-angled triangle will be actually built along the length of side A. And actually we drew side B in the same line of side A. We draw side B, and then we raised a perpendicular whose length is the size of side B. Okay, so now we have two triangles, ABC in the right side and ABC in the left side. Whose two sides are equal to each other. Side A in this triangle is equal to side A in this triangle, and side B in this triangle is equal to side B in this triangle. And also the angle between side A and side B in this triangle is equal to the angle between side A and side B in this triangle, and it is actually 90 degrees, because in this triangle it is the right angle that is equals to 90 degrees, and in this triangle it is also 90 degrees, because that is how we built the side A. The side A is actually perpendicular to side B, and for that reason it is actually 90 degrees. Therefore the triangle ABC on the right side coincides with the triangle ABC on the left side, according to the rule side angle side. Side, angle, and side. That is to say, two triangles that have two sides that are equal to each other, and also the angle between these sides is equal to each other, in both triangles, so the triangles are congruent or coincides. So as I already said, side A equals to side A, side B is equal to side B, and this is 90 degrees, and also this is also 90 degrees. So we have two sides that equal in both the triangles, and also the this is the 90 degrees, and this is also 90 degrees. So the angle between the side A and side B are equal in both sides. That is 90 degrees, and for that reason, actually, triangle ABC is coincides with in the right side is coincides with triangle ABC in the left side. Okay. According to the law, side angle side. Okay, and since the third side of triangle ABC in the right side is C, then because of the overlap of the two triangles, then the third side of triangle ABC in the left side is also must be C. Then the third side of the triangle ABC on the left is also C. Okay. Now let's mark the angle between side A and side C with alpha. The angle between side A and side B in the red is marked with alpha. Also the angle in this triangle between side A and side C is marked in red in alpha. As we know, the sum of the angles in a triangle is equal to 130 degrees. Therefore, the angle between the sides A and C will be, if we doesn't know what angle is it, so we will mark it as x. So x plus 90 plus alpha equals to 180 degrees. As you can see here, x plus 90 plus alpha is equals to 180 degrees, and therefore x is equals to 19 minus alpha, because we actually can deduct 90 from both sides of the equation, and then we will subtract alpha from both sides of the equation, so we will get that x is equals to 90 minus alpha. Okay, so as it is written here, x is equals to 90 minus alpha, and since the sum of the angles on a straight line is 180 degrees, so in this line the sum of the angles alpha plus y plus x is equals to 180 degrees. So we don't know what size is the angle between C and C, so we will mark it as y, as unknown variables, but we know that alpha plus y plus x that equals to 90 minus alpha is equals to 180 degrees because of the fact that the sum of the angles between a straight line is equals to 180 degrees. Okay, so as you can see here, alpha plus y plus 19 minus alpha is equals to 180 degrees, because it is alpha plus y plus 19 minus alpha equals to 180 degrees. And then alpha minus alpha is 0, and then we will subtract 90 from both sides of the equation, and then we will get that y is equals to 90 degrees. So this angle y is equals to 90 degrees. And on the one end, the area of the trapeze is equal to the sum of the parallel sides. The area of this trapeze is equal to the sum of the parallel sides. Side A is parallel to B, so it is A plus B. Multiply the height of the trapeze. The height of this trapeze is this. This is the height, it is A plus B. So it is A plus B times A plus B. Divide by 2, or in mathematical notation is A plus B times A plus B divided by 2 equals to A plus B squared divided by 2. Okay, so this is one way to calculate the area of this trapeze. The area is equals to A plus B squared divided by 2. On the other end, the area of the trapeze is equal to the sum of the areas of these three triangles. Yes, so the area of this triangle is A times B divided by 2, and so is the area of this triangle is equals to A times B divided by 2, and the area of the middle triangle is C times C divided by 2. So in total we have the area of the first triangle is A plus B, A times B divided by 2, plus the area of the third triangle is the same area, is A times B divided by 2, plus the area of the middle triangle, that is C times C divided by 2. So in total, actually we have A times B divided by 2 plus A times B divided by 2 is equals 2 times A times B divided by 2. It is actually A times B plus C squared divided by 2. Okay? So actually by comparing the two expressions, we got to each other, we get the Pythagorean theorem. So we calculated the area of this trapeze in two ways. First of all, we said that the area is actually the sum of the parallel sides times the sum of the height divided by 2. That is actually a plus b squared divided by 2. This is first way to calculate the area of the trapeze. And the second way to calculate the area of the trapeze is actually, it is the sum of the three triangles. That is actually a times b plus c squared divided by 2. That is the area of the middle triangle. So actually the right side is equals to the left side because it is the same area. We calculated the same area in two different ways. So actually they of course equals to each other. And now we can multiply by 2 this equation. And then when we multiply by 2, we will get a plus b times a plus b. The 2 is cancelled. And then c squared divided by 2 times 2 is c squared. And then a times b multiplied by 2 is 2ab. And then if we open the brackets, we will get that a times a is a squared. Then b times b is b squared. And b times a plus a times b is actually 2ab is equals to c squared plus 2ab. Here we can actually deduct from the two sides of the equation the expression 2ab, and then we will get that a squared plus b squared is equals to c squared. And this is exactly the Pythagorean theorem that says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Okay, so actually we proved the Pythagorean theorem. Okay, thank you very much.